Hey, it's T. I'm one of the geniuses at Ask Zylor. So let's just get started with the live session. So we're asked to prove this identity. So a couple of things I'm going to mention are some tips and tricks for trig identities. So the first thing is that we should always be trying to solve the hardest side and match it with the easier side, right? So given this trig identity, we're going to start with the hardest side. So we're going to try and solve this, the left side, and try to match that with the right side, right? So let's deal with the left side first. Another thing is that if we have tan, always convert that into sine and cos. So try to convert them into the primary trig ratios. So tan, I'm going to convert that into sine and cos. Cotangent, I'm going to convert that into sine and cos as well. So let's get started with the left side. So I have cos theta. I'm just going to rewrite the equations. 1 minus tan theta is plus sine theta over 1 minus cotangent theta. Right? So my first step is to change each of these into sine and cos. So tan I know is going to be sine over cos, so 1 minus sine theta over cos theta. And that's added with sine theta. And cotangent I know is cos theta over sine theta. So I'm going to replace that with that. So cos theta over sine theta. Right? So my next step should be to try and make these denominators the same, right? So that I can add them and get it into one term. So what I could do is get rid of the cos in the denominator by multiplying both the top and the bottom by cos. So I'm going to multiply the top by cos, the bottom by cos. This will eliminate my denominator of cos, right? I'm going to do the same for the right hand side. So I'm going to multiply both sides by sine, so I can get rid of the sine in the denominator. Right? This will give me cos squared theta over cos times 1 is cos theta. Sine over cos times cos, I get just sine theta. Right? Do the same thing for the other side. Sine squared theta over 1 times cos, 1 times sine theta is sine theta, and cos over sine times sine is 1 sine minus cos theta. Right? Now we're close to getting it in the same denominator, so we can do the lowest common denominator and then add them together. Right? So what we could do is just factor a -1 from the left side, the left fraction. So I have a negative sine theta minus cos theta over cos squared theta. Right? And this is, I'm not changing the right hand side. So now I have a common denominator I can add the two fractions together with. So I can just translate the negative to the numerator. So I have minus cos squared theta plus sine squared theta gives me sine theta minus cos theta. Right? So I can rearrange the top to give me a difference of squares. So sine squared theta minus cos squared theta over sine theta minus cos theta. And looking at the top, it gives me the difference of squares, so I can factor that to give me sine theta minus cos theta, sine squared plus cos theta. Sine theta plus cos theta. Right? Now if we observe that we have the same term in the denominator and the numerator, I can cancel those out. Right, so what am I left with? I have just sine theta plus cos theta, which is what I had initially at the very top on my right hand side. Okay, so the steps we're taking is always, when we're dealing with trig identities, is to try and solve the harder side or the more complicated side. If both of them look complicated, just pick one and try to simplify it. And if we look at these two terms, the left one has two fractions, the right is just one term. So that should indicate that we should combine the two fractions into one term. So that's why we try to get in the common denominator form, right? And the next thing is that if you get a tan or cotangent or secant or cosecant, try to convert it into the primary trig ratios as much as possible, right? The sine, cos, and tan. Okay, so we'll move on to the next question. Okay, so we're going to do a grade 12 calculus and vectors question next. So we're given the velocity of a certain particle as v of t. So I'm going to rewrite that. So it's 10 times e to the power of negative kt, where k is a positive constant and vt is in centimeters per second. Show that the acceleration of the particle is proportional to the constant multiple of its velocity. So what we should be doing is trying to find the derivative of my velocity to get my acceleration function, right? So the derivative of my velocity would end up being 10, I'm going to leave that the way it is, and I'm going to look at e to the power of negative kt. So e to the power of negative kt will yield me negative k, e negative kt, right? Negative k is a positive number, right? The negative makes it a negative, obviously. So what happens is I'm basically getting the derivative of e to the power of x. What happens when I get that is going to be the exact same function, right? Because e to the power x is a special function. The derivative of e to the power x is just e to the power x. So now if I have a number being multiplied into my x, I do the chain rule, so I get the derivative of e to the power x and the derivative of k to the power of k times x, right? So that just gives me k times e to the power of kx. So that's what I have over here. So notice if we take out the negative k, so my acceleration function is equal to negative k times 10 to the power of e negative kt. Notice how 10 times e to the negative kt is the exact same as my velocity, right? So the only thing I need to look at is this number in front of it, which is the negative k. So because this is a negative number, we know that the particle will be slowing down, because it's always going to give me a negative number, right? So v of t is positive and decreasing. Okay. Why is v of t positive? We just need to look at the velocity function. It's a positive 10, so it's positive, but it is decreasing. Right. So we'll just do part B quickly. So what is the initial velocity of the particle? So what I'm going to do is substitute 0 for t. So I have 10 to the times e to the negative k times 0. Right. 0 times k doesn't really matter. It's going to give me 0. So 10 times e to the power of 0 is just going to be 10 centimeters per second. So just to recap what we did, they're asking me to show that the acceleration of the particle is proportional to the constant multiple of its velocity. So we went ahead and found the acceleration function. We found that it is a constant multiple of the velocity function. It's just the velocity times negative k. Right? And we found that the particle is slowing down because the acceleration is negative. The velocity is, however, positive. Okay, so we'll move on to the next question. So this is also a grade 12 calculus and vectors question. It's dealing with curve sketching. So we're given a function 2 cos x minus sine 2x, where x is an element of negative pi to pi. Determine all the critical number for f of x on the given interval. So the critical numbers is when my derivative is equal to 0, right? What are my x values? So we need to go ahead and find the derivative first. So I'm going to find the derivative. So I have 2 cos x, so the derivative of 2 cos x is going to be negative 2 sine x. And then the derivative of sine is going to be just cos, so cos 2x times 2. Right. So this is equal to negative 2. I can factor the negative to give me sine x plus cos 2x. Right. This is equal to my derivative function. Now they're asking me to find the critical points, right? So my derivative should equal to 0. So I'm going to substitute that with 0, and then I can find what my x values are. Right? So it's going to be equal to -2 sine x plus cos 2x. Now I'm going to isolate for my x's so I can divide both sides by -2. So that gives me 0 is equal to sine x plus cos 2x. Right? And then I can bring one term to the other side, or I can try and factor this. Right? I can replace the cos 2x with 1 minus 2 sine squared x, so 0 is equal to sine x minus, or we'll make it plus, 1 minus 2 sine squared x. Right? Then I'm going to expand and simplify. So I have 2 sine squared x, so that's minus 2 sine squared x plus sine x plus 1. Right? If I factor out the negative, I don't like the -2, so I'm just going to factor out a negative to give me 2 sine squared x minus sine x minus 1. Right? So now I can try and factor this, which gives me 2 sine x plus 1, and then sine x minus 1. Right? So now I can evaluate when each of these is equal to 0, that's when my critical points will exist. Right? So I'm going to do 2 sine x plus 1 equal to 0. I'm going to do sine x minus 1 equal to 0 and evaluate my x values. So I have sine x is equal to -1/2. My x is equal to basically pi/6. Right? So my sign is a negative, so think about the unit circle again. When is it going to be negative? It's when it's in the third and fourth quadrant. Right? So if my related acute angle is pi/6, I can figure out what the principal angles are for the third and fourth quadrant. So I can do pi plus pi/6, and then I can do 2 pi minus pi/6. Those are the two values which will yield sine x is equal to -1/2. So my x could be 7 pi/6, right? Or it could be 11 pi/6, but we need to consider the range given to us, right? It needs to be between -pi and pi. Right? So -pi and pi would be between over here, -pi, which is pi over here, right? And -pi will be going clockwise towards the pi again. So let me just rewrite this. So pi is over there, -pi would be, if I have the sine function, it's going to look something like this. Right, so I'm looking in between these 2 points. So since we can't have 7 pi/6 in between the range of -pi and pi, what I could do is just subtract the period from 7 pi/6, right? So 2 pi minus 7 pi/6 is going to give me -5 pi/6. Right? I'm going to do the same for the other one, so 2 pi minus 11 pi/6 is going to give me -pi/6. Okay. So I found 1/2 of the critical values. The other equation I still need to solve. So that sine x minus 1 is equal to 0. So sine x minus 1 is equal to 0. Right? So then I'm looking at when is sine x equal to 1. Right? Looking back at the unit circle again, sine x is 1 at pi/2, right? So my x could be pi/2. So between, again, I need to look at the range between pi and pi, -pi and pi, pi over 2 can exist, so that's another point I can look at. So the three critical values I'm going to look at, critical numbers, are when x is equal to negative pi over 6, negative pi over 6, and pi over 2. Okay, so that's one part of the question done. So the next part is determine the intervals where f of x is increasing and where it is decreasing. So we need to, given the critical points, we need to make a table of intervals, right? So we need to find out what's happening from negative pi and when it's less than negative 5 pi over 6, negative 5 pi over 6, and what's happening between that and negative pi over 6, right? And there's two more, so there's going to be negative pi over 6, x, pi over 2, and the last one will be from pi over 2 to pi. Right. So what are we looking at? We are looking at the increase and decrease, so we're looking at the derivative of f of x. Right. So what we could do is just sub in a value into my derivative, and between negative pi and negative 5 pi over 6. So that should give me a negative value. I'm just going to save time. Right. And again, I'm going to plug in a value between negative 5 pi over 6 and negative pi over 6. That should give me a positive. And this should be negative, and this should be negative as well. Right. So the negative and positive is telling me when is it increasing, when is it decreasing. This is my derivative, f prime of x. So if that is negative, that's telling me my function f of x is decreasing. Right? If it's positive, that tells me my function is increasing. Right? And the last two are decreasing as well. Right? So what does that tell me about the critical points we got? Negative 5 pi over 6, negative pi over 6, and pi over 2. We can figure out, is it the minimum or maximum? So if it's going from decreasing to increasing, that means my graph is going to look something like this. It's decreasing first, then increasing, which tells me there's a local minimum in this point, which is negative 5 pi over 6. Right? If it's going from increasing to decreasing, it's the opposite. So it's increasing, then decreasing. That tells me there's a local maximum. Okay? And then similarly, if we have the pi over 2, if we're going from decreasing to decreasing, that means there's no real change. So we have an inflection point at pi over 2. Okay, so let's see the next part. So determine all local max and minimum values. So we figured that out using the critical points. Use the information you found above to graph the sketch, graph this curve. So I'm just going to put all this together. Right. So we found, I'm going to make this more clear. So we know our functions between negative pi and pi. Right. And we found three critical points. One is at, let's say, negative 5 pi over 6. One is at pi over, what was the other one? Pi over 6, that's also negative. And one's at pi over 2. Right, so I'll say this is pi over 2. Now I can find the exact values by plugging them into my function, f of x. Right? So when I plug them in, I should get, it's roughly negative 2.6, let's say. Right? And the negative pi over 6 would give me roughly 2.6 as well. Right. And the pi over 2 will give me 0. Right. And we know the intervals of increase and decrease. From negative pi to negative 5 pi over 6, we said it's decreasing, right? So it should be going downwards until it hits this local minimum. Then it's going to go upwards because I have my function's increasing now until negative pi over 6, which is all the way up here. So I'm going to say it's going to look something like this. right? Then we have a local maximum at negative pi over 2, pi over 6. Then my next point is my point of inflection, which is my x-intercept coincidentally. So it's going to cross through, and it's not really going to change the increasing or decreasing. It's going to keep decreasing, right? So it's saying it's an inflection point, so I'm going to draw it like one, and then it's going to keep decreasing until it hits pi. So this is the rough outline of what it should look like. So we use the critical points to figure out, is it a local min-max or is it an inflection point? Then we use them to find out if it's a local min-max, and if the function is increasing and decreasing, and then we just plug it back into my original function to find the actual y values. Okay, so we'll move on to the next question. So this is a grade 11 functions question, so it's dealing with angles greater than 90 degrees. So which of the following are equal to sine 30? Right? So let's evaluate, instead of evaluating all of them, I'm just going to evaluate part E. Okay? So I have negative sine of negative 150 degrees. Right? So let's draw the unit circle. So I know this is CAST. Okay? Negative 150. So that means I'm going counterclockwise. Right? So I'm starting over here, which is 0 and 2 pi. I'm going, let's use degrees, so 0 and 360. So I'm going 150 degrees clockwise, so it should end up over here. Right? So this is negative 150 degrees. So I can find the related acute angle by doing 180 minus 150, which gives me 30 degrees. Right? Now they ask me which of the following is equal to sine 30 degrees. So just sine 30 will be in the first quadrant with 30. Right? So however, they're giving me negative sine negative 150. Right? So the negative 150, again, we're going clockwise, so we ended up in the third quadrant. So we know sine is negative. So I know my sine 30 should be a negative, but there's a negative outside it, so I'm going to multiply them together to give me sine 30 degrees. Right? So these guys are equivalent, so I found that answer. So once again, just to summarize, the sine of 150 is negative because it is in the third quadrant, and the only positive primary trig ratio is the tan. Right? The sine and cos are both negative in the third quadrant. So let's move on to the next question. So this is a grade 9 math question, so it's dealing with linear relation application problems. Right? We're asked to find the initial values of these questions, these problems, the rate of change, and the meaning of the rate of change in this situation. Right? So we have two conditions, two situations. One's a flash delivery and one's an express delivery. So the flash delivery, let me write this down, is C is equal to 3D. Right? D represents the distance. The package is shipped in kilometers, so this distance in kilometers, and C, let's say, is the total cost. Right, so what's my initial value for this equation? I have none because I'm not really adding anything in the beginning, right? So if C is equal to 3D, there's no value I'm adding, so it's just plus 0. So my initial value will just be 0. Right? My rate of change, on the other hand, depends on what number is being multiplied by D. So in this situation, it's going to be 3. So I'm going to put 3 there. Right? So what's the meaning of the rate of change in this situation? It's basically telling me what is the cost per kilometer. Okay? So now let's look at the second situation where we're given the total cost versus the mass of the package. So we have kilograms and then we have the cost in dollars. So initial value is given 0 kilograms, what is the cost? So that we can find out by looking at the y-intercept, which is 5. So my initial value is going to be 5. Right? Then they ask me what's my rate of change. So how do we find the rate of change? We have to find the slope. And the equation for the slope is y2 minus y1 over x2 minus x1. Right? So I can pick 2 points, any 2 points on the graph, and plug them into this equation. Okay? So let's say I'm using 2 and 10, and 0 and 5. Right? So I'm going to do 10 minus 5 over 2 minus 0, which gives me 5 over 2. So my slope is 5 over 2, so that's going to be my rate of change. So it's going to be 5 over 2. Now my final part is asking me what's the meaning of the rate of change in this situation. So now I'm looking at what's my rise, what's my run. My rise is the cost. My run is what's the mass of the package. So it's going to ask for what's the cost per kilogram. So all you need to do is look at the units of the x and y axis and figure out what's the rise. In this case, it's the cost in dollars. What's the run? It's in kilograms. So it's going to be cost per kilogram. So we'll move on to the next question. So this is another grade 9 math question. It's finding the equation of the line. So we're given a set of data and we're asked to find the slope, right? Find an equation for the line. So let's say this is all the information given to us. So how can we find the equation of the line? So the equation is usually in the form of the slope y-intercept form. So it's y is equal to mx plus b. Right? So let's go ahead and find slope first. So my slope, I can use 2 points. So I can use this and this. Right? So I can do negative 17 minus 5 over 26 minus 14. Right? So my slope ends up being negative 12 over 12, which is just negative 1 then. So I found one part of the equation. So I know my equation is negative x plus b. Right? Now I need to find what b is. So once again, I can use any of the 2 points. So I'm going to use 14 and negative 5. And I can plug them into this equation because I have 3 variables, y, x, and b. And I can use this point to substitute the y and x. So I can find the b. Right? So I'm substituting negative 5 is equal to 14, but it's negative 14, plus b. Right? So my b will be equal to 14 minus 5, which gives me 9. Right? So I found both parts of the equation in the slope y-intercept, so I found the slope to be negative 1. So that's times x, and my y-intercept to be 9, so I'll just add 9 at the end. So this is my equation for the line. Okay? So once again, if you have any questions you want us to answer, please send them in. We'll be happy to help you. The next live will be this Wednesday, so stay tuned for that, and hope you guys have a good night. Take care.